Assalamu alaikum. Today, my team members Sabiha Ahmed, Tamanna Akhtar, and I are excited to present on real-life applications of matrices. Let's dive right in. Here is what we'll cover. Introduction to matrices, basic operations, transforming vectors, solving systems of equations, Markov matrices in population dynamics with a fun zombie example, image processing with matrices, applications in computer graphics, graph theory and network analysis, and finally conclusion. This presentation explores the various applications of matrices inspired by concepts covered in the video, the applications of matrices, what I wished my teachers told me a way earlier. Matrix is just a grid of numbers like an Excel sheet. But it's not just math homework. Matrices can power things like Google search rankings, PageRank algorithm, medical imaging and MRI scanning, video games for 3D graphics. Also, matrices are fundamental in numerous fields including circuits, electronics, image processing, quantum mechanics, and various types of networks. This presentation aims to provide insights into these applications and their significance because they are the hidden tool behind modern technology. Before we jump to cool uses, let's recap some basics. Matrix addition. Matrix addition is performed by adding corresponding entries from the matrices. It's like combining datas. For example, merging two images. It is one of the simplest operations and forms the basis for more complex manipulations. Scalar multiplication. Scalar multiplication involves multiplying every entry in a matrix by a single number. This operation is straightforward but crucial for scaling matrices. Actually, matrix multiplication is crucial for animations, like rotating a character in a game or scaling them. Matrix multiplication is a bit more complex, involving the row by column dot product. It is essential for many advanced applications, although it often lacks context in basic courses.
Vector transformations. Think of a vector as a arrow pointing in space. When you multiply it by a matrix scaling, like zooming in or out on a photo, a matrix can stretch a vector by 2 times or shrink to half its size. Rotation. Imagine turning a phone screen from portrait to landscape. That's a rotation matrix in action. Why it matters? Robotics. Robot arms use matrix to calculate joint movements. GPS. Your location on maps is transformed using matrices. Eigenvector or eigenvalues. These are special vectors that don't change direction when transformed, just their length scales. Used in facial recognitions, identifying unique face features, quantum mechanics, describing particle states. Solving systems equations. Matrix representations. Systems of equations can be represented using matrices, where the coefficients from one matrix and the variables and constant from other matrix, the matrix from simplify solving these systems. Inverse matrix. Finding an inverse matrix allow for solving system of equations by essentially reversing the transformations applied by the original matrix. Application in circuits. In complex circuits, matrix can represent the linear equations governing the system, allowing for easier analysis and solutions through computational methods. Markov matrix in population dynamics. Markov matrices are used to model systems that change over time, such as populations in a quantized school during a zombie outbreak. By applying specific percentage of change over discrete intervals, this matrix can predict long-term population distributions. For example, starting with equal humans and zombies, the system can be modeled to show how population stabilize over time.
Image processing with Matrix. Raise your hand if you have ever used a photo filter. Did you know every Instagram filter is just Matrix math in disguise? Pixel math. Every photo is a grid of numbers. Bright pixels are high values, dark ones are low. Show a zoomed in pixel grid. Turner operations demonstrate with hand motions. Blurring is equal to averaging neighbors. Open hands wide. Edge detection highlighting differences finger tracing motion. Real-world impact. When doctors enhance MRI scans, they are using these same matrix operations to save lives. Now that we have seen how matrix touch our personal lives, let's scale up to blockbuster visuals. Applications in computer graphics. Interactive Start, WhoWare plays 3D games. The characters you move are just puppets controlled by Matrix. Matrix are used to perform geometric transformations such as scaling, rotating, reflecting, and translating images and objects within a coordinate system. This is fundamental for creating and manipulating visual content in both 2D and 3D graphics. Industry examples: Pixar uses these techniques to make each layer on Sally move realistically. Next time you watch Avengers, remember Thanos' snap was powered by matrix multiplication. Graph theory and network analysis. Let's play a game. Imagine you are Facebook's algorithm. How would you decide who to suggest as friends? Adjacency matrix demo. Draw a mini social network on whiteboard. In graph theory, adjacency matrix represent the connections between nodes, making it possible to analyze complex networks like social connections, communication networks, and more. Path counting. Exponentiating the adjacency matrix reveals the number of paths of various lengths between nodes. This technique helps in identifying critical nodes and connections within the network. Real-life examples. Applications of graph theory using matrix include social network analysis, internet web page ranking, and identifying key figures in organizational structures such as in criminal networks. Matrices are powerful tools that extend beyond basic arithmetic operations. Their applications in various fields such as electronics, image processing, computer graphics, and network analysis demonstrate their versatility and importance. Understanding and utilizing metrics can lead to significant advancements in technology and science. From zombies to zoom filters, metrics are everywhere. They are not just numbers. They are the language of tech, science, and even social media. Next time you edit a photo or play a game, remember a matrix made it possible.